Hey everybody, this is Larry. This is me going over Q3 of the weekly contest 257. First day where you have been in all the rooms. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like this room. Get it? I don't know. But yeah, join me on Discord and we'll chat about this room and other problems. Yeah. So this one is very hard. So it took me the longest. It took me about half an hour and I got a wrong answer. The wrong answer was that because I was trying to simulate it, I misunderstood the constraints, which happens from time to time. And I thought that you can't revisit states. But there are a couple of things that I would think about solving this problem. I think that I did notice these things in the beginning, but I didn't put together in a coherent way into the solution that I end up doing. And basically the idea is that, and this is such short amount of code for this problem, but the understanding is the hard part. But the idea is that the first notice is that n is 10 to the 5th, so you can't do anything n squared in case you want to. And the number can get really big. In fact, if it's all zeros, it gets to like 2 to the n or something like that, or 2 to the n minus 2 or something like that. So yeah. But the key thing to notice in this problem is this thing. What does this mean? That means that on the ith index, the next visit will only... You would always go backwards. You never go forward, right? So I didn't really notice, or I didn't, when I first read this problem, I didn't notice this. But once you notice that you can only go backwards, it becomes interesting, right? Because now there's parity. Because now basically you want to visit a room twice. And then the idea that I thought about, and I kind of did it with an example to be honest, and I really had a lot of trouble with this until I kind of wrote it out on a piece of paper. I think I was a little arrogant about it, but yeah. But because this can only go backwards, what does this mean, right? This means that you can only visit the ith room. Let's say we care about this room, for example. We only care about this room if we visit the previous room twice, right? Yeah. And then same thing for here and so forth. So then the question is, how many steps are there to get from this loop? And the answer is, okay, and then we'll go through it one by one to kind of visualize it, because that's what I did during the contest. But yeah, but the first number has to be 0, so it goes to itself 1, so then it has 2 steps, right? 2 days. And then the first day, what happens? Well, this one is 2 steps because now it goes back to itself, so this is 2. Of course, we also keep track of the prefix sum, just for fun. But yeah. And you'll see why in a second. And again, if you don't, I usually go over prefix sum, but for now, this problem, I'm not going to go over prefix sum because I want to focus on this particular hard part. If you have trouble with prefix sum, check out some of my older videos on prefix sum or solve easier problems on prefix sum. So that's definitely something that you need to kind of, this is a very basic application, so it's not that hard once you notice or understand prefix sum more. Anyway, so this goes to 0, right? So what does it mean to go 0? That means that now, the first time it gets here, it takes these, the sum of these steps plus 1 for getting, for moving 1 more. So that's 5, for example. Yeah, is that right? No. Well, it's what I said is 5, but you have to do 1 more step to leave it. So that's why I did it to 6. So basically, this is saying, okay, this has 2 things, right? One is 1 step into this thing. So this is 1 step plus. So the cost of this step is just 1. Wait. Well, yeah, so it would take 4 steps, get to here, plus 1, and then now, how am I phrasing this incorrectly? Yeah, so basically every time you go here, it will take How many steps? I think that's the question. And the answer happens to be 6. Why is it 6? Is it 6? Let me check what I did. Sorry, friends. Yeah, I get confused now because this is a very tricky problem. But oh yeah, it is 6. Yeah, the reason why this is because what was my logic? Sorry, friends. I am recording these live, so maybe skip ahead a little bit. But yeah, but basically the idea is that okay, the first time you visit, you will have to visit. Oh yeah, okay, I get it. So basically, the first time you visit, you're sent back to 0. So then now it takes 4 steps to get back here, plus 1 more for the step. So your initial step to go back to 0 is 1, and then now you take these 4 steps. So that's 4 plus 1 more to leave to the next step, right? So this means that this step takes 6 thing to process, and that means for now we'll do the prefix sum as 10. So what about this 1, right? Well, this 1, like the same thing before. Now that you're here, what does it mean? So we take 1 step to go to this one, and then here we take 8 steps to get back here, and then 1 more to go out. So this is equal to 10. So this is 10, and also prefix sum is 20. And I've missed the prefix sum. This is 2. Okay. So hopefully you're starting to get the pattern, right? So this is 2. So now you have 1 step coming in. So now you go to 2. So 0, 1, 2. Now you take 6 plus 10. So this is 16 plus 1 to go. So that's 18, right? And this is 38. So that's basically the idea about this. And the short answer is that every time you go back, you're going to loop through all these things to get the sum, right? Plus 2 to kind of end. So 1 is for the first step to go to that number, and then you take the sum of all these numbers in between. So sum x plus 1, in this case, to kind of leave to the next number, right? In this case, it is just 38 plus 2, so this is 40. And this is where the prefix sum comes in. If you are, if you've done enough Leetcode contests, you'll probably recognize this, is that to get the sum of any subsegment, that is just basically the sum of so this is what the prefix sum means. We prefix it with 0. But to get, for example, between 6 to 18, let's say we care about this segment, that means that for using prefix sum, we just take this segment minus this segment. So here, for example, so here the 2 we want to get here to here. So that means that it is, in this case, is here minus this one. So that means that it is 20 minus 4, which is 16, because this is the length of this segment. And then you have 18, right? Because the length of this segment is just the length of this minus this, so you have 18. Again, I'm hand waving a little bit on the prefix sum because I go over this a lot. So look at another video because I want to get through this quickly. But yeah, but that's actually pretty much it though. So now you kind of look through it every step at the time, and then just make sure you calculate the prefix sum. And again, the code is very, it's like 10 lines of code, but the understanding is hard, and it took me half an hour and a wrong answer to a time limit exceeded to come up with this. Yeah, this is basically what I said. This is basically the sum between the previous index and the last element, and then we added 2, 1 for entering, 1 for leaving. We also have to care about the mod, and then we add to the prefix sum. And then this is just the one more thing to notice is that we don't care what the last number is, because as soon as you hit the last number, you visited everything, right? So this is just the prefix sum of all the numbers here. So then that is why I have this thing. And of course, I'm off by 1, I'm padding it by 1 extra number. And the first number is always 2 because the first number is always 0. So that's why I have this. But yeah, and you can see that this is linear time and linear space very easily. Hopefully that makes sense. So I'm not going to, explain that part. But yeah, that's all I have for this one. Let me know what you think. And watch me solve it live during the contest next. What I was doing, but what a silly 5 minutes. Okay. Um. Okay, come on, Harry. Focus, focus. All right, no one solved it yet. Okay, the end rooms you need a visit from. Mod. I'm gonna be very sad that I wasted 5 minutes on the of penalty on the other one, because because this one seems like it's gonna be a little bit hard, and then it's gonna be a huge penalty, silly penalty. Okay, so you start 0, and then you go to the next visit of 0. I plus 1 mod n. Okay, so you just go to the next one if you've been in either number of times. I think this mod thing is a lie. I think this mod thing is a lie. You can only go to each room twice, so we just simulate it. Okay, so maybe this isn't so bad, but it's still terrible. Unless I'm wrong. I feel like there's no way to go back and forth. No, yeah, I don't think there's a infinite loop, and if there's an infinite loop, there's just no answer anyway. So that doesn't even make sense. So, okay. Okay. Including the current exit, okay. Where's possible? We go to 1, we go to... Okay, and then now to turn the days. Yeah, I don't think that's possible. I think that's just a lie. But almost clicked on something by accident. 377, so I think I'm okay, except I'm just off by 1. Yeah, okay. I think I'm should be right on this case. Come on, let me submit. Okay, has to be at least 2. Is that a constraint? Why is that? Huh, that's actually weird, but okay. Actually, I didn't even think that's a possible case, but okay, whatever. Let's give it a submit. If I get it wrong, I just misunderstood the problem. Oh, if it's TLE, that would be interesting too. And maybe I did misunderstand the problem. Maybe today's a sloppy day. Why is this wrong? Oh, so I am wrong in that, and this isn't even that long of an input. In that you can go back to 0. I don't know why I submit on that. This is just I'm tilted from problem 2, I think. Okay, so let's actually think about this for a second. Also, people would have solved it. I really should have guessed this if that was this easy, but so okay, so why is this wrong? So okay, let's actually do something even simpler. I think this just degenerates to like 2 to the n or something. I was wrong about yeah, -2 or something, but I guess I was wrong about. Man, I've been very sloppy today, both in the morning contest and the afternoon contest. Okay, how do I learn from this though? So I just don't know how to solve this, at least not off my head. I mean, I think there's some caching type thing too, but always test on a big example. But yeah, I was really wrong on this one. Okay. Okay, let me think about it for a second. This is clearly wrong, but at least it gives me an answer that is right. I feel like there's some caching thing that we can do, but so basically it goes from 0, 1. And when we visit it again, it basically, how do I solve this actually? That's a good problem actually. I assumed wrong. I really should have paid attention, but okay. And also that I can have this thing, but now it's all ones. Right. So we can't really just single out the zeros. Well, I think this thing is the key thing. That means that we should be able to solve it backwards. I think I overlooked this. I mean, I saw it, but I overlooked it in thinking about this problem. But I think that means that the answer to this problem is when you visit the last cell, and then from that you can think about it backwards. Okay. Maybe. Because basically it is just that you need to go to this point twice, right? So that means that What does that mean in terms of if it is 3 space back? What does that mean? It means that all the previous numbers are 1 or odd numbers. Okay. And that means that if it is 1 space back, then it is just. So basically, for example, let me actually undelete this so I could test more test cases. If you have something like 0, 1, 2, 9, I guess doesn't really matter, but this is just 2 twice on each one, right? So this just adds a step. If it's 2 steps back, what does that mean? I guess it doesn't really matter, but index, but so the number of ways to get to here is just equal to explicit of index if parity is equal to 0, then we return looking backwards. Okay, so then now if for every step that it goes back, we calculate how far is it from the distance, right? That means that this will have to be odd, maybe. That means that the previous number to visit this one, well, this is a little bit awkward, I think. So I think maybe that's why. The last number doesn't matter. We have to skip ahead 1 number, so. And we want it to be. We want it to be even. This one's hard. But okay, so this means that, so the next visit doesn't actually matter. So this is actually n-2. So we want actually to go from n, so we want to see how many ways to get to n-2 where it is on a even state. And then you add 1 to it because you go to the next step. Okay, so then now let's say we're here and we're at even. How do we get it to be even? Well, we get it to be even if we get this to be even if the previous number is even as well. That okay, but that doesn't. I mean, yes, so if all the numbers are visited once, or that number, then that would be it. But that's not good enough. So then, okay. I mean, I guess this is technically true, but I don't know that this is good enough for me to figure out. And then if index is 0, that means that we can't do it anymore. Then we have to figure out how to get to odd, right? How many people have gotten this? Wow, I am really a mess today. Wow, people already solved it all. Good job. A lot of people solved this actually. Maybe I'm just thinking about this in a poor way. If backwards doesn't work. So okay, how do let me think about it another way. How do we get this to be an odd? So this is an odd if odd. Okay, so how do we get all this to be an odd number? Let's say right. Okay, so this just goes twice, and then here it goes 1, and so this goes also twice. Here it goes back, so this is 2. So it takes 2 to get to here, and then this is 8, and then 64. Is that even right? I need my wrong solution to kind of figure out. Also, this may be just +2, so. I don't know if this is not that worth saving, so. I'm still in the exploration phase. I thought I had some idea of DP with that, but it's not quite right. Actually, and apparently I was wrong anyway on this 2 plus thing. So I think this is. So what happens when you visit the same state again? How do we skip ahead? I mean, this is the key, but I don't know how to unlock it. This goes to 1. And this goes to 1, and then this goes back to 0. Right, and then 1. So this goes to 1, and then this, and then it goes to 0, and then here it comes back again. So then now it goes to 1, but then now this is 1. Oops. So then now we want to. Then this goes back to 0, and then this goes a second time, and then we do here, right? But how do I code this? How many people have self-queued for? Not that many either, so maybe they're both tough. Now I really feel sad that I got 5 minutes on Q2 penalty. Because where am I? 199 because of that 5 minutes. Would have been pretty fast actually. Would have been actually top 10 if I didn't. Oh no, that's not true. I have to solve this one first. Okay, focus, Larry. Okay, I think there is some simulation thing we can do and then figure it out how to do it. Yeah, because we do it one day at a time. So then now instead of this, we do something less, more funky. Which is that, okay. What is the farthest that I can go yet, right? Because basically, you can only ever go farthest. You can only go farthest one at a time. So then it's almost like a weird sliding window-y thing, but I don't quite know how to code it. And n is big, so I can't do anything n square, which is obvious maybe. But I come back again. What does that mean? What happens? What does it mean when you revisit a state? Maybe you have something like this. Well, okay. I guess with an actual answer though. You have some weird funky number. I really don't have any idea. This is so mathy. I think there's some hour left. I'm gonna just use my pen and paper. I'm gonna spend too much time thinking in my head. Let's see how that goes. Yeah, so what happens if we have a case like this? So we know that every cycle, right? So okay, so this is gonna take 2 moves. This also takes 2 moves. This takes okay. What does this take? 1 0. So 10. That means that this takes 6 moves. Why does that take 6 moves on the 3rd step? Because the last number doesn't matter. Because this basically takes. Okay. So in order to flip this to 1, you have 4 moves, so it takes 4 moves to get here. and then it gets back, and then this is now 6 moves. Okay, so then that means that this is 2, 2, and okay, I think I have an idea. Let's see what happens if we add one more 1. I mean, I know that the numbers don't matter, but I'm just trying to gauge whether, what is the last number? 20. Okay, why is this 20? Now we're going to 1. So 1. So then it takes this subset, it takes 8 moves plus 1, and then now it takes another 8 moves. Did I put 8 here? So this takes 6 moves altogether, this takes 8. It got here, and then takes another 8 to come back. Okay. I could buy that. 8 plus 1 day plus the 1 to the next, so that's 10. So then now that's okay. And then now let's try a random number that I wouldn't have expected. So let's say 2 and 1. So what does that mean? If I'm right, then this should be 18. So that means that it will be 38. Okay. Huh. This is a good problem. But I really should. I think I took too long to get to the paper, because this is something that usually I'm really good at. But I think I just tried to do too much in my head in Leetcode. Maybe I am too cocky, too arrogant about this one. But okay. Let's see. Okay. So now, how do we want to do it? Prefix sum is equal to or even just that, it doesn't really matter. The first number is always going to be 2, just the way it is. And then now we can do something like for index in range of from 1 to n, maybe. Yeah, I don't know, maybe this is off by 1, but basically now, how many, what is this number? What is next visit? Next visit of index, so pre-index, say, the previous index is equal, so then now we take the prefix sum from that, from prefix of p-index, including that index to the number that is, so then this is just this minus 1, and then prefix of the, okay, so it's this number is the total plus 2. So prefix dot append this plus 2. We have to add a 0 here so that we don't get our bounds, but that means that everything gets plus 1. How does this go again? No, I guess this is still the last number. That's actually kind of awkward. Okay, and then now we just return prefix of the last number, so something like that. 242, is this right? Nope. Okay, well, where did I go wrong? Well, this is clearly not 2, so this should be Okay, so this is 1, so this should add 2. So this means that the last number minus this plus 2. So this is not right, because p index of 1 should be 0, so this should contain, well actually it should just contain 2, right? Am I saying that right? That's what I wrote down, but I think I messed up something. Maybe I just got lucky on that. I mean, I think like I'm close, but I think I am a little bit awkward as well. In that this is not the prefix. Or rather, this is the cost of the last number, but it is not the prefix sum. And we don't care about this number. So actually this is just the sum of these, and I think that would actually be right, because this is the cost, but we have to do the prefix sum. So is this so the cost is this thing, and then the prefix sum is just this thing, and then maybe we're right. Okay, and then now we have that other number. Let's see, what was it? I hope this is 38. Yep. And then now let's try some big numbers. Oops. I think I have to mod, by the way. Mod. Before I forget, mod. Be mod. Larry, please mod before I forget. Okay, let's mod this, and also mod these things. Okay. Let's give it a go. I don't want to spend 5 minutes debugging. Maybe I always say that, but if you get accepted, you're like, I didn't waste time. But if you don't get accepted, you're like, oh, why didn't I spend the time debugging? Okay, that took way too long. Hey, yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord, and come hang out with me. Yeah, stay good, stay healthy. Hope you have a great rest of the week. Hope you had a great contest. Anyway, see you later, and yeah, to good mental health. Bye-bye.